Hi everyone, welcome. Today we will be talking about API security, and with us we have our expert from USAA, Hieu. Hieu, do you want to introduce yourself?
Yes, my name is Nguyen, and I am with USAA as a security architect, focused on the identity and access management. In this presentation, we will talk about USAA API security journey through an insurance claim use case.
And my name is Payal. I'm the Regional Principal Solutions Engineer at Okta, focused on all things identity, but mainly focused around customer identity and API security side of things. So this is just our safe harbor statement. It says that this presentation may have forward-looking statements. You're going to see this throughout the 2 days in every presentation. All right, so we'll be talking about today, why should businesses care about API security? And then what makes APIs vulnerable? We'll also look at the Oauth API security top 10 list, the threats. And then we'll talk about how do you go about protecting your APIs. We'll look at some of the architectural patterns that help you secure your APIs as well. And then ultimately, we'll talk to Hieu on how USAA protects their APIs too. And then we will have the chat on so you can ask questions and answers anytime throughout the presentation. And API security is a very vast topic to be covered in 45 minutes, to be honest. And our hope is that you can take away some new things today from this conversation. So the first part, right? Why should you even care about API security? Let's talk about that first. What happens when there's a breach? Developer gets called lazy in most instances, and I don't think that's fair. Bugs appear in the code not because developers are lazy or they don't care about, secure code and code quality. It's because businesses prioritize quick delivery of code or in working function over the delivery of a more secure code that may take some more time. And ideally, you want to incorporate security in your tools and your deployment process, your pipeline, and treat it as a daily part of your work. Hence the shift from DevOps to DevSecOps. And your red and blue team exercises are very critical during this whole deployment cycle as well. And while there has been a lot of focus around, securing the web apps, your databases, your infrastructure, hackers are looking to find easy targets, and those happen to be APIs. APIs have become a de facto in modern application architectures, and then they tend to expose really critical data about your customers, your employees, your business data, which is why APIs have become a very high value target for these hackers. And when I say hackers, these could be ethical hackers as well, right? We're just trying to help you. And APIs are therefore considered the weakest link in the applications today. So let's start with some examples of some recent breaches. This is the one where the personal data for 6.5 million Israeli voters got exposed, and this happened sometime in February. You'll see with this attack, the URL here, I basically took a screenshot, but the URL here for the, or the endpoint for the API basically provides information about the admins. And you'll see that the response also returns the password of the admins in clear text. Now, one of the issues with this endpoint, this was embedded in the code of the application, and it was accessible without any authentication. So the first lesson learned here is always protect sensitive information and endpoints with authentication and authorization. And this is going to be our theme of the, basically throughout the conversation today, is just focus on authentication and authorization and get deeper into that too. Of course, amongst covering some other threats as well. And then the other part from this that we learned from this hack is, first of all, never store or transport credentials in clear text, and never return credentials in the response as well in your JSON object. You want to limit the data exposure and only return what's required by your client at that point. Let's look at another example. This is where Starbucks developers left API keys in GitHub public repo. Now we see this all the time, right? Time and time again, this type of a issue shows up. Now this API, in this example, the API key was embedded in the code, and it pretty much had a lot of power to access the user's information, to be able to, and also be able to single sign on into the user's AWS account, and from there on find additional information and basically leading to the AWS account takeover. API keys should never be used alone for authentication. API keys carry a lot of power. It basically is a key, provides keys to the kingdom. And, they don't really follow this principle of least privilege when it comes to providing that security. And also they tend to be long-lived. So you want to make sure that, you're not using these. And if you are using them today, please make sure that you're securing you're storing it in a secure vault. Another one is basic authentication, right? Very similar, where you're using your username and password to authenticate against an API. And the problem is every time you're passing the username and password to access your API is where the problem lies. If you are using basic auth and, in exchange for a short-lived token, like an Oauth token, then it's acceptable. And of course, all of this has to be over HTTPS. So what makes APIs vulnerable? So we looked at a couple of examples, and you may have seen this list, the API security top 10 list from Oauth. This was released a few months ago. And Oauth, they basically develop and maintain an ongoing top 10 list of the risks related to the APIs that the organizations face. And this is very similar to the top 10 web application security risks that they release every 2 to 3 years. And this list also provides example attack scenarios and mitigation techniques. The highlighted ones here are the ones that we will be focusing on. That's the broken object level authorization, broken user authentication, and broken function level authorization. But if you look at it at a very high level, some of these are very similar to their browser-based counterparts, like the broken user authentication, authorization, excessive data exposure. We saw that in the Israeli voter data breach example where the password was exposed. Security misconfiguration. This is where the attackers are looking for something as simple as a missing TLS. Injection. This is very similar to SQL injection, but you're injecting malicious data within APIs. And insufficient logging and monitoring. But some of these vulnerabilities or risks that are called out are very unique to APIs, like the broken object level authorization, and we'll look at this one a little bit deeper later. And mass assignment. This is where by design APIs tend to expose a lot of the implementation details. Basically, the way it works is you are mapping your client inputs and binding that directly to the code variables and objects in the backend. So for an attacker, it's very easy to guess and manipulate the API requests. Another one is rate limiting and also improper asset management. This is where you have lack of service discovery, as well as managing different versions of your APIs. So let's look at before we look at the three that we highlighted earlier, I also want to talk about the NIST guidelines that we have here for securing my microservices. So this is a very cool, just document going over almost like 98 controls that are listed out. And all of these tools that are available, the OWASP and the NIST publication, these should be basically used as guidelines. You as an organization may not need all of this from your business standpoint or from your API standpoint, but this is a great reference for you guys to look at. So let's get deeper into the three vulnerabilities that we talked about earlier. So broken object level authorization. We'll call it BOLA from now on. But this is where the APIs endpoints that expose the endpoints that handle object identifiers. These could be either user ID, as in the case of this Panera Bread breach, where a user can easily increment the user ID in the endpoint and access another user's information. The other one is by object ID, where you can access objects that you're not entitled for by just incrementing the object IDs, like the document IDs in case of this First American corporation breach. And so let's see, how do you go about mitigating this BOLA? So first of all, authorization. That is the key. You have to make sure that object level authorization checks must be added at every function level. And it should be checked against the policy engine as well. For example, in this case, you want to make sure that the user 123 who is trying to access the document 1001 has access to this document, and you have to check that against the policy engine. This is where you would define your fine-grained policies and authorization rules. And this can be pretty much, flexible depending on what system you're using. Another example is you want to make sure that user 234 is allowed to update the profile for user 123. As you can see here, the user 234 is trying to update user 123's email with his own email, and that seems malicious. So you want to avoid scenarios like this. And you want to do proper testing for these types of scenarios. This can get really complex and hard to test, but that's something you need to watch for. Also, you want to make sure that when it comes to using these object IDs, you want to use something that's unpredictable, like the GUIDs for record IDs. That's something that, cannot be easily guessed and be, by just incrementing. Also, you can think about tokenization, encryption, all of those options here as well. Let's look at broken user authentication. Now, this is focused on the API endpoints that are responsible for authentication and must be treated very differently from the other endpoints, as these endpoints, the ones focused on the authentication, are vulnerable to credential stuffing and brute force types of attacks. These would be like authentication APIs, your password reset APIs, MFA endpoints, any of these, right? Like in this example with SoundCloud, there was a flaw that was found where their sign-in password endpoint did not implement proper account lockout controls based on a failed authentication. So what happened was the attacker could basically just continue credential stuffing and take over the account. So the recommendation here would be, first of all, don't even build your own authentication and MFA, and use solutions like Okta, where this problem has already been solved. But if you do end up implementing a solution by yourself, you want to make sure you implement account lockout mechanism based on failed authentication attempts, like, maybe lockout after, say, 5 attempts for authentication. And you want to have more restrictive rate limiting policies too, so that people are not coming from like different IPs and trying to do that, and you let that through. And you want to implement MFA wherever possible as well. And don't accept, when it comes to JOT tokens, if you're using that for, accessing your APIs too, and you want to validate your JOTs for like an initial authentication, you want to make sure the JOTs are not signed with weak algorithms. Plus, you want to make sure, that you validate the authenticity of the JOT too. And let's look at the broken function level authorization. With broken function level authorization, this happens when a user can make legit calls to the API that they're not authorized to. Let's look at one example here. This is where, the Venmo APIs, if you guys have looked at this one from a breach standpoint. So Venmo basically provides this API, that's a public API, to provide all the transactions, even for strangers or people you don't know, right? And Venmo does this on purpose, but I mean, there's a lot of issues with this. First of all, and it's all public. They only make it private if the user chooses to do so. The issues with this is an attacker was actually able to download gigabytes of data with this one. And, the biggest issue that can happen is, so if I see, as an attacker, I see that this user 1 is always sending regularly money to this user 2, I can easily target them for spear phishing types of attacks. So you want to be careful about that. And you want to, by default, you want to make these APIs private and only allow access for your own transactions. Another example for broken function level authorization would be where you can easily change the API method of the endpoint, say from a get to a post, and be able to create or update records that you typically are not authorized to. So when it comes to access management, you want to deny access by default and explicitly grant permissions to specific roles and only for specific functions. You want to ensure that your APIs can only be invoked by clients that need to be invoking them as well. So while a lot of the responsibility falls on the developer for securing APIs, let's look at some of the architectural patterns that can help you bake security during the development cycle and also share responsibilities when it comes to security with others, right? And while we will be focusing a lot on authentication and authorization for the APIs today, these architectural patterns will also help mitigate most of the vulnerabilities that we just saw on the Oauth API security top 10 list. So in a typical application architecture, you have your clients, you have your external clients, your mobile client, web client, IoT, could be B2B, and you'll notice that the API traffic flow typically goes from external to the external callers to the internal services, and this is considered the north-south traffic. And once you're inside your network, there's typically not a lot of controls in place, as traditionally security models operate on this outdated assumption that everything inside the organization or inside organization's network should be trusted. Modern application architectures, if you look at them nowadays, they enable internal service-to-service communications, like in this microservices world, this whole east-west traffic, right? And they can be very chatty. Like in this example, the shopping cart service is trying to calculate the shipping and handling for this user, and the shipping and handling service in turn calls the customer account service to look up for the user's address and maybe the membership level, right? So this east-west communication represents a very critical risk surface because of its ability to move laterally if the attacker gains access to your internal network. So you want to make sure you secure communication between your clients and your services, as well as between services. So your north-south traffic, as well as your east-west traffic. And it's very critical for the operations of the microservices-based applications. So earlier we saw this API gateway. It acts as a central interface for your clients using these APIs, so that your clients, instead of having to call every API individually and managing the calls there, the client can just send a single request to the API gateway, which will then route to the appropriate service in the backend. Now, while the primary function of the API gateway is routing, you will see that there's plenty of other security functions like rate limiting, managing traffics, and also access quotas and throttling. This is where it helps, mitigate API risks like the lack of resources and rate limiting. And then also input validations that can help with risks like injection. Also whitelisting allowable methods, authentication authorization with IDPs like Okta, and then also transformation that can help limit and filter data from an exposure standpoint. And then, I get this question all the time from customers. Hey, I have an API gateway in place. Is that enough? Isn't that enough for my API security? While the API gateway provides a lot of the key functions from securing your API standpoint, you still need to be able to do the authentication and authorization from a user or a client standpoint. So this is where the who has access to what is where the identity and access management solution comes into picture with something like Okta. So you want to make sure that, typically all your users are managed within your identity management solution like Okta. And in that case, that's where the user's life cycle is managed. That's where the user's policies are managed. And, you would not want to replicate that information, that data in the API gateway and also manage separate policies there. Typically, what would happen if the user is deactivated from their identity and access management system, or if their policy changes and they have a live token, that token can be immediately revoked based on their life cycle, right? Versus if, you were to manage all of that in the API gateway, then really there's no real-time way for the API gateway to know that this user's life cycle has changed. So you're not getting that real-time revocation of the tokens, and then the user can continue to access your APIs. And this pattern helps mitigate broken authentication and authorization as well. So authentication as the identity provider like Okta will provide you all the benefits from, strong password hashing, account lockout mechanisms, rate limitings, MFA, all of that just built into the solution. And also helps with the authorization aspects related to the risk, where you verify the authorization policies at the user level. We'll talk about the object level later, but for the user level, by their roles and scopes that are defined within Okta's OAuth engine. So let's look at what authentication looks like in the north-south traffic. In an application, the users or clients will first authenticate against Okta, and Okta will in turn return a ID token and an access token. And these are typically JWT tokens, JSON Web Tokens. ID token is used for single sign-on and getting specific user profile attributes, and the access token carry the scope of authorization on what this user is allowed to do. And both of these tokens tend to have, they also have an expiry time, so they could be short-lived. The access token is then passed to the API gateway. The API gateway then authenticates the client with the client ID and client secret, and also validates the access token by checking for the proper signatures and authenticity, as well as the expiry and some other parameters. So that's authentication. Now let's look at authorization, what that looks like in the north-south traffic. For authorization, then once the API gateway has validated the JWT token, it then checks for scopes within the token to see if this user trying to access the API is allowed to do the functions that it is asking for. In this example, so the customer is able to read and write their own, the address for their own account, but a customer service agent should only be able to read the address for this customer's account and not more than that. And so that's where once this validation or checking for scopes is done, then the API gateway passes the token to the service, which then responds to the client based on the scopes that are passed in the token. Now remember, OAuth provides coarse-grained authorization at this point, and it's not meant for fine-grained authorizations. So something like an object-level security, that's not something what OAuth should be used for. Fine-grained authorizations are a lot more complex, and we'll talk about that briefly too. So now we looked at north-south traffic. Let's look at the east-west traffic. So API gateways usually implemented as a lightweight, it's actually implemented as a tightly controlled shared infrastructure, typically managed by a platform team or an integration team. And there's typically one API gateway deployed at the edge of the enterprise network, and it provides all the services to the APIs at the enterprise level. Now, but when it comes to your internal services, why would you go through your external API gateway to talk, to your internal services? And for east-west traffic, what I've noticed is customers also have maybe another gateway deployed, and that's internal to your network. And that's where they use that for more service-to-service type of authentications. Now, monolithic gateways can do quite a bit, but when it comes to, they can also become a bottleneck when it comes to continuous deployment and development of your APIs. Gateways really have a single core function, and that is to expose your API endpoints to the external clients and route the requests to the proper services that they are trying to access. And if you think about it, right, this is a shared layer, so you want to be careful not to put a lot of business logic in this layer too. Now, enter microservices world. If you're evolving your monolithic application to the microservices within your organization, applications are typically composed of fine-grained services and do a lot more than just talk externally. They also talk internally quite verbosely. And this is all typically done through APIs. Now, unlike the application development in the previous architecture we saw, individual microservices are built by very small teams, and they choose to use their own tools and coding languages, and they have their own delivery cycles that's independent of other teams and other services. And basically, microservices are built independently while they communicate with each other constantly. The idea is decoupling, right? And the whole idea is that you want to decouple so that they can individually fail without escalating into an application-wide outage. Each service has its own entry point, and as your services grow, like to say maybe hundreds of services, entry points to these systems increases as well, right? So when entry points increase, the attack surface increase, which is why it's very critical to secure this east-west communication between them. How do you go about securing communication between these microservices without having any latency? How do you go about even, tracking these hundreds and thousands of transactions that happen between, even millions for that matter, between these services? And how do you scale and manage hundreds of services via API gateways? So this is where, an API micro gateway can be helpful in this architecture, where you could have multiple instances of these micro gateways, where a micro gateway is a very lightweight scriptable API gateway optimized to run in a containerized environment. And it's deployed closer to the microservice APIs and provides a very similar security benefit from a security benefit standpoint, similar functionality to what the API gateway provides. And microservices are designed to enforce policies and business logics very close to the service endpoints, rather than having some logic in a very centralized API gateway. These are generally provided, the micro gateways they're typically provided by your API gateway providers as a solution to secure east-west traffic. And you may have heard of a service mesh. Service mesh is much like a micro gateway. It basically controls how your different services communicate with one another and abstracts this network communication from the API business logic. So the service meshes handle the service-to-service communication, the interactions, including load balancing, this whole job validation from an authentication standpoint, service discovery, routing, and then also authentication from service-to-service standpoint with mutual TLS, where it enables both services that are in an exchange of data to authenticate with one another. And then the JOT that's sent out from the API gateway, it also handles that from an authentication standpoint, as well as use the information that's sent in the JOT for authorization purposes and defines local authorizations as well. So local authorizations with you can do local authorizations with RBAC or ABAC based on the user attributes and roles that are sent in the JOT token. And you can also enforce complex, fine-grained access policies that are very close to your service. And again, you can use something like an open policy agent if you'd like, or there are a lot of other solutions available, or you may bake that into your code, but that's all defined close to the service that the service mesh can help you with. So I know this is a lot, and there's a lot going on here, but this is the most latest and the greatest architecture that's being leveraged by organizations who are adopting microservices. And adopting a service mesh allows for developers to focus on business logic without having to worry about the complexities of securing the communications between the services, as well as the whole network function aspects of it. So we looked at a bunch of architectures here, architecture patterns that you can use as guidelines for API security from, north-south traffic as well as the east-west traffic standpoint. So now let's chat with Hieu to understand how USAA secures their API. Hi, Hieu. Can you tell us a little bit about USAA?
Yes, USAA is a unique organization. And this is founded by military for military. Our mission is to provide our service member, associate, and their family with a full range of competitive financial products and services. In doing so, we live our USA standard by keeping our membership and mission first, reflect our core value, caring to each other, and keep innovating to improve the current process and target for future.
Awesome. And then can you tell us about your business challenge and the use case that we'll be talking about when it comes to API security?
Yes. And as you know, the insurance claims business is a complex one. That's where many parties are involved with different business functions, such as filing a claim from a consumer, car towing, repair estimate by adjuster, repair work by collision shop, and rental agency, and of course, many more. Their activities sometimes intertwine with each other and overlap their timeline. This means functionally they crossing each other because they have to communicate back and forth between parties. Currently, our service reps handle million calls just for checking on the claim status. So we want to provide a better experience for our customer in self-service, using self-service to do that, as well as reduce non-essential workload on our service rep. We want to have a digital channel for all involved parties using the most modern frameworks, such as microservices, with a strong emphasis on end-to-end security and consumer data protection. We want to have a reusable set of API that can leverage effectively by different parties and still meeting the privacy concern on data sharing. With a proper IAM solution where we could get the right level of authentication and authorization based on either group or user profile or risk to create this type of application. This is the powerful paradigm in developing business functionality, expand with API, and build everything built on infrastructure specifically designed to handle microservices.
That's a great use case. And then what does your API ecosystem look like today?
Okay, so let's starting from the back-end system first. So then we move to the front, to the when the user coming in. We know that to build an API ecosystem, the first thing we need to have all the component, the critical component in place. That we have to have a great IDP system that provide rich authentication and authorization that based on industry standards, so it can be scaled. The standards such as Oauth and OIDC. Then the next thing is we need to have an API management platform where developer can publish and manage their API, then automate the whole system. And everything has to work together with the IDP to provide the authorization for the API itself. And finally, microservices, the modern microservices are running on container orchestration like Kubernetes. And everything on the Kubernetes wrapped inside the thing that you mentioned before is a service mesh. That service mesh provides management capability and security function that to secure the container. We move next to the next level that, okay. So I think you have discussed the architecture pattern before, that we have the API gateway on the edge. And so when the developer using API management publish their API, they will be pushed to the API gateway. That where at the edge, we provide the protection for all the backend system. And as you're talking about, the edge gateway can have many functions, and security is a major one that play into play, right? They orchestrate the whole flow of checking for the API permission and checking for the core that's only certain domain can come in, and checking for a QoS, the rate limiting. So API gateway managing many things that we need on from a security standpoint. And also we're talking about how to have ability to logging every transaction they coming in. So the other thing people can say that does a token have permission? How do you proving that? So all that thing will be done inside the API gateway. Next, we move to the application side. The application side is uniquely to provide the user identity, and that connects you back to the IDP to provide type of authentication. It depends on the risk from the user standpoint, from the business to see if the user coming in that perform a high level of transaction or high risk transaction, then you can stepping up to do MFA and so on. So the application can, based on the user authenticate use the identity, can do a group or attribute-based access control. And based on that, this is a new thing that we can see that the behavior of the application change based on identity. Finally, we talk about the user, right? That is critical from the consumer standpoint. They want to have the application that's customized for them and provide them with a great authentication mechanism from user password or go to all the way to MFA with different type of using FIDO or using WebAuthn. All that thing need to have a rich authentication engine. And we talking about like Okta providing all that MFA SMS to WebAuthn and so on. So that customize that thing for user to enhance their experience. And finally, when we have an application that complex like we are talking about here, that between different party, sometimes party have to ask the user for permission to share the data with them. So that's where we have the privacy coming in through consent.
Okay. And so in the specific use case that we've been talking about, how are you guys doing API security for your mobile app? I know we talked about this whole ecosystem, but let's talk about your architecture.
Yes, but it's coincident that what you're talking about before we are applying very similar pattern, right? From the claimant, when they go in using application, they will be authenticated, right? Every function there, they will be protected, and they will go out to Okta to authenticate in. And like I say, depend on not just the claimant. If I am a insurance adjuster coming in, we need them to do MFA, and automatically based on that identity, we kick in the MFA. But other claimants that they just want to check for their own status, they just using the basic auth. So once they have authenticate, the IDP will look at their profile and look at their group they belong to. They can authorize the correct tokens. And here we are talking about two types of token. The ID token that really used for authentication or session management, and allow the application to know who is the authenticated member, so they can display the information, on the screen, right? The second token is really about authorization. It's an access token, and that access token is used just for API. So the ID token will stay on the application. The access token will be used for API call. Then now on the step 3, when we send the access token down to the API gateway we discussed before, we check for, we make the call back to, say, for example, to Okta to do the token introspection. They will check for the subject, the issuer, timeline, all that. If it come back, we take out the scope on the access token and verify that against the token, the scope that published on the API. Remember, on the gateway, when the developer push their API into the gateway, they also define what API scope that required to get through them, right? That's authorization. Yep. So once they match up, we can go to, now we allow them to invoke, to move on, route into the back-end system. But we're not stopping there yet. We say that, hey, back-end we need, so the back-end we need additional data. So that's when we generate a party token, and that party token will be used for local authorization that you mentioned before.
Okay. So that's the party token that you're passing down to your services, right?
Right. That's for local authorization. Mostly that will be done based on the business logic. For example, that subject will be checked against the business database to see where they are on their claims, right? If they're asking for some status and that's already been settled, then that call will be failed at the API level.
That makes sense. And that's where you're going to be doing more fine-grained authorizations like I talked about earlier, and that's going to be more closer to your service, your business logic.
Correct.
Awesome. And then how are you guys setting up, one more question. How do you set up communication between your services? That looks like you guys are using neutral TLS, all built in with service mesh.
Correct. So the service mesh right now is the Kubernetes is the Istio, for example. They would use the MTLS to authenticate between services, right? And that will be guaranteed between service A and service B, it's only authorized to talk to each other. And so we implement the same way with the proxy or the sidecar to do that function.
Okay. And then what is shifting gears, right? What does your microservices secure development cycle looks like? Do you guys follow the guidelines like from OWASP and the NIST within USAA?
That's correct. And the developer would go through a lot of training also, And we also automate in the pipeline, and we put in the DAS and the SAS to check for all the code base in our repository before they publish into the pipeline. And even that, the testing team will do the dynamics testing to make sure that everything fit into the OSWAP, all the vulnerability before it can be published to the gateway.
Okay. Awesome. Thank you, Hieu. And I'm sure we'll have questions from the audience as well. But in closing, I just want to reiterate that the architecture patterns we saw, actually want to keep this here so they can look at that again. Sure. The architecture patterns that we saw really help you adopt this, the whole zero trust security approach through the authentication on who the service or the user is, as well as whether, they can be trusted, and the authorization aspect on what specific permissions do they have for this service. And together, these protect your environment from security threats like, broken authentication and authorization. And also this architecture helps with many of the other API risks that we saw earlier in the Oauth API security top 10 list to keep your organization and your customers' data safe. So following these guidelines and architectures will greatly reduce this coding, the coding efforts for developers, and making your applications far more efficient, secure, and decrease the API risks all at the same time.
Correct.
And please post your questions on chat. And also want to talk about, so we have 3 other sessions that are kind of closer to this whole API security topic. If you want to go super deep into in the coding level, you do have the security patterns for microservices architecture from Matt Rabel that I highly recommend. There's also APIs in a regulated world. If you do come from the regulated world, or you may end up there someday, definitely attend this too from Keith. And then what's new in OIDC and Oauth? This is from Aaron Perek. He stayed from the standards committee, so you'll hear a lot over there too. So thank you again, Hieu, and we'll wrap it up.
Thank you.